CeeLo Beats Production.
Good morning, I'm Madam Immaculate. Today I'll be taking you through decimals, our topic in Form 1. So our topic today will be decimals. That is our today's topic. Form 1 work, mathematics. And the topic is decimals. So in this topic today, we are going to look at some major things. The first thing, we are going to look at how we convert fractions into decimals, and also the vice versa, how we are also going to convert decimals into fractions. That will be our first objective. The second one, we are going to look at recurring decimals. The other one, we are going to look at how we convert those recurring decimals into fractions. The other one, we are going to look at rounding off the decimal numbers into specific decimal places. For example, you can be told to round off those decimals to 1, 2, or 3, even more decimal places. Then the other one, we're going to look at standard form, writing a number in standard form. And the last one, we're going to look at basic operations on decimals. So let us start up with our first objective, which is converting fractions into decimals. Converting fractions into decimals. Let us start with simpler examples. So for example, our first, you can be given a fraction whereby you can be told convert the following fractions into decimals, and our first fraction, let us say, be it maybe a half. So when converting fractions into decimals, you first of all have to take the numerator and divide it by the denominator. So here we're going to use the long method. 1, we divide by 2. So since 1 cannot be divided by 2, we have our answer here as 0, then we put a decimal place and add a 0 there. So we have now 10 divided by 2. 10 divided by 2, we all know that it is 5. Then if we take 5 multiplied by 2, this is 10, and our answer, we get here that a half, when a half is converted into a decimal, it becomes 0.5. So the major thing to know on how to convert fractions into decimals, it is just by taking the numerator, dividing it by the denominator. Then I can give another example. We can say maybe a fraction like 3 over 4. 3 over 4, we are also going to divide it again. So the long method, the numerator divided by the denominator, which is 4. So 3 divided by 4, again, it's impossible. So this one will be 0. We add a 0 here. 30 divided by 4, it will be 7. Because of 7 times 4, this will be 28. Then 30 minus 28, this is 2. Then since 2 cannot be divided by 4, we can still add another 0 to become 20. 20 divided by 4, this will be 5. So 5 times 4, this is 20. And our answer here becomes 0.75. So that is how we convert fractions into decimals. We can also look at how we'll convert now the vice versa from decimals to fractions. If you are given a decimal place and you are being told to convert it into a fraction, we can have, let me give one example. So let's say this is, you are given, convert 0.25, maybe 0.25 into a fraction. So when we have to convert this, first of all, we know that 0.25, this is the same as 25 over 100. Then from there, we can simplify. You just can't leave it at this point. You have to simplify that fraction to a simpler form. So we are going to divide here by 5. This will be 5. By 5, this will be 20. by 5 1, by 5 4. So we are getting that the fraction is 4. Thereby 0.25, when it's converted into a fraction, the fraction is 1/4, which is the same as a quarter. I can also give a last example. We have, maybe if we have a 0.125. When converting also that one into a fraction, we first of all have to write, this is with the same as saying it is 125 all over, it has 3 decimal places, so this will be 1,000. Then after there, we are going to divide the fraction to make it into a simpler form. So here by 5, this will be 2, then 5. By 5, this will be 200. We can still not leave it at that point. We have to divide further. By 5, this will be 5. By 5, this will be 4, 0. Then again, by 5, 1. By 5, this is 8. So we have found that our number 0.125 into a fraction, it is 1/8. So that is how we convert fractions into decimals and decimals into fractions. Let me just brief you again. Fractions into decimals, you have to take the numerator, divide it by the denominator, just using the long method. And then decimals into fractions, you first of all convert that decimal number into a fraction that is of the numbers 10, 100, or 1,000, then according to the decimal places. Then from there, you simplify it to the simplest form. So that is how we convert fractions into decimals and decimals into fractions. As I remind you, our topic today is decimals, and this is Form 1 work. We've already achieved our first objective. We now know how to convert fractions into decimals and decimals into fractions. So our next thing that we are going to look at is how we identify recurring decimals. Recurring decimals. So recurring decimals, these are decimal numbers whereby the fractions, these are decimal fractions whereby one digit or even more than one digit repeat themselves continuously without ending. So I can give an example. And since, for example, if we have a fraction like a third, let's convert this fraction into a decimal. So if we convert this one, as we said earlier, we're going to take 1 divided by 3. So this will be 0. We add a 0 here. 10 divided by 3, it is 3 because of 9. So we subtract, this will be 1. We add another 0. 10 divided by 3, again it will be 3 because of 9. 1, 0. 10 divided by 3, it will be 3 because of 9. So we'll just continue like that. It will never end. So this one, we can say this is a recurring decimal because we have our digit 3, it is repeating itself. If we continue, we can continue until tomorrow. So I'll just leave it at that point. And since we can't write the whole of those digits because this will be 3, 3, 3, 3, 3, 3, we are going to write this as 0.3. Then we place a dot on top of the digit that is repeating itself. That is how we write recurring decimals. So this is just an example of how we identify a recurring decimals. So this one, we are going to, if we have a third, we've seen that it is giving us 0.3333. So we are just going to write it 0.3. We cannot write it as a 0. Maybe you say it 3, 3, then you place it here. It will still be the same, but since the digit is the same, we just have to write the one digit like that and put the dot above 3 like that. So that is the first example of a recurring decimal. So if we have a number like, maybe for example, we have a decimal like 0.454545. To write it as a continuously, in this example here, we are seeing that the digits that are repeating themselves are 4 and 5, 4 and 5, 4 and 5. So this one can be written as, this will be 0. We have the digits that are repeating themselves, 4, 5. Then we place a dot on top of 4 and 5 to mean that both the digits 4 and 5 are repeating themselves. So that is the second example of how we write recurring decimals. We can also have an example whereby the digits, we have 3 digits that are repeating themselves. For example, let's say we have a number like 0.324, 324, 324 continuously. So in this number, we can see that the digits that are repeating themselves, we have there 3, 2, and 4. So here, we are going to write this one as 0.324. And since the 3 digits are repeating themselves, the dot is going to be placed on top of 3 and on top of 4. We're not going to put it on top of 2 because that one shows that the repeating digits are from 3 to 4. Thereby, our number, this one is written as that. So those are 3 examples of how we write recurring decimals. I now want us now to find how, we are going to change fractions that are recurring decimals into fractions. I'll give you some examples. I hope you've now all known how to change or to write the recurring decimals in the proper way. So let us express the following as fractions. Express the following as fractions. So we're going to look at how we express recurring decimals as fractions. The first example I'll give is 0.6, and the recurring digit is 6. So here we are going to introduce a letter. Sorry. So we're going to say maybe let this digit 0.6, we know that it is written as 0.6666666 continuously. So we're going to say let maybe a number or a letter R be, which is this one, 0.6666 continuously, like that. So we're going to express this number in terms of tens. For example, the next thing we're going to look at is 10R. If R is 0.6, our 10R will move the decimal one step forwards towards the right. So this will be 10R will be given by 6.6666 continuously. So here we have that. The first thing you should know is that we have to identify two numbers whereby after the decimal place, the digits after the decimal place should be alike, such that if we subtract, we get that past the decimal place, we should not get any number. The number that we are going to get here after subtracting should be a whole number, not a decimal number. So if you look at this, our digit R, from the right after the decimal place, we have digit 6. Also, 10R, from the right, we have the digit 66 repeating themselves. So thereby, we have that we can already take the 2 and subtract. So we're going to replace our R here, which was 0.6666 continuously. So we're going to subtract from there. So if we subtract here, you can see that after the decimal place, it will be 66, so that will be 0. Then 6 minus 0, this will be 6. Then 10R minus R, this is the same as 9R. So after we have gotten that, we are going to find the value of R, which will be now our fraction. So we're going to divide both sides by 9, and here by 9. So our R will be 6 over 9, whereby we can't write it as 6 over 9 because that one is not in the simplest form. It can still be divided further. So if we divide here, this will be by 3, this will be 2 by 3, 3. So our number R will be 2 over 3, whereby we've gotten that our recurring decimal, which was 0.6, when it is converted into a fraction, the fraction itself is 2 over 3. I hope that one is well understood. I can give another example. So we can have maybe a number 0.73, and the recurring decimal is at 3. This means that the number 0.73 and the recurring dot at 3, it means that the digit that is repeating itself is 3 alone, not 7 and 3. It is only 3. So this one we can say, let our R be 0.7333. As you can see, the digit that has repeated itself is only 3. There was no 7. if maybe there was a dot here at 7, it will be 737373. So we have our R as that one. We just follow like that example. Next it will be 10R. Our 10R will be 7. It will move the decimal place to one step on the right. This will be 7.333333. So if you look at on the right side after the decimal place, they are not alike because the first one was 7333 and the other one is 33. So we just continue until we find that they'll be the same. So our next will be 100R, which will be, we move 2 steps from the original one. So the decimal place will be after the first 3, that will be 73.3333 and continuously like that. So if we have those, we have three digits here. The first one 0.733, the second one 7.33, and the third one 73.33. So we're going to look at the two numbers whereby from the right side of the decimal place they are equal. So we have our 10R here, because after the decimal place the digits are 3's, and also 100R after the decimal place the digits are 3's. So we're going to take the larger number, we subtract the lower number. So this one will be, we just replace this one here. So our 10R, we're not going to use this one because from the decimal place towards the right is not equal. So we replace our digit here, 10R is equals to 7.3333, continuously like that. So we subtract there. This one will be 0. Then here it will have, this one is 66. Yeah, that will be 66 is equals to 100R minus 10R. This will be 90R. Then as usual we have to remain with our R. So we're going to divide both sides by 90 and here by 90. So our R will be given by, we simplify this to its simplest form. So by 2, 33, by 2, 45, good. By 3, this will be 11. By 3, this will be 15. 11 over 15, we cannot simplify further. So we have our R as 11 over 15. We've seen that our recurring decimal 0.73, when it is converted to a fraction, it is 11 over 15. So maybe you can look at another example. Sorry, we're dealing with recurring decimals. I want us now to look at a recurring decimal whereby we have 3 digits that are repeating themselves. You see how that will come out. So we have a digit like, let's take, let me use here. Let's have a digit like 0.324, and the recurring decimals are there. So this one, our R will be 0.324324 continuously like that. So we are going to find the number whereby after the decimal place we have digits that are equal. So we are going to follow step by step. 10R, this will be 3.24324 continuously. They are not the same, so we just continue. 100R, this will be, it will move 2 steps, so it will be 32.4324324 continuously. We still do not have 2 numbers that are equal after the decimal place. This is 324, this is 243, this is 432. So we still continue. We have 1000R, which will be 324 point, because it will move 3 steps towards the right, 324.324 continuously. So if you look at those, we have 4 digits there, whereby our first digit, which was R, this was 0.324, which we can see that from R and 1000R, we have the digits on the right after the decimal place are equal. So we're going to use this one and this one. So we replace our R below the 1000 R here, R is equals to, this was 0.324324. Then we subtract. If we subtract here 1000 R minus R, this is 999. R is equals to 324 minus 0, this will be 324. So we still have to get our R, whereby we are going to divide all through by 999. By 999, this will cancel out. So we have our R will be equals to, then we have to simplify now until we remain with the simplest form of the fraction. Let's start by 3. By 3, this will be 1, then this will be 0, then 8. By 3, this will be 3. Then again, we can still divide by 3. By 3, this will be 3, 6. Yes. By 3, this will be 1, 1, 1. We can still divide further by 3. So by 3, this will be 1, 2. By 3, this will be 3. Then 21 by 3, this will be 7. So we have 12 over 37. Can 12 over 37 be simplified further? No, it can't. So our fraction R, so we've gotten that our R will be given by 12 over 37. So when 12 over 37 is expressed into a decimal, we are going to find that it will be a recurring decimal, which will be written as 0.324, and the dots will be on top of 4 and 3. So that is how we convert recurring decimals into fractions. So let us see if we can be able to identify, given that given a fraction, how can you be able to identify if that fraction is a recurring decimal? Maybe we look at a fraction like 15 over 33. So we have 15 over 33. You've been told to identify that fraction if it is a recurring decimal. And if it is a recurring decimal, you write it correctly the way it is supposed to be written. So 15 over 33, we are going to use the long division method. So this will be 15 divided by 33. So I hope you can still do this one, because 15 divided by 3, it cannot be divided. So we have to put, this will be a 0 here, point. Then we add 0. Then 150 divided by 33, this will be 4, because of 2, 12, then because of 132. Then if we subtract there, we'll borrow 1 here to remain 4. This will be 10. 10 minus 2, this will be 8. 4 minus 3, this will be 1. Then we add another 0. 180 divided by 33, this will be 5, because of 5, 15, 16. Yeah, that will be times 5. Yeah, that is correct. So we subtract 180 minus 65, this will be 5. Then 7 minus 6, this will be 1. We continue, so it will be 150. We add another 0, then we continue, it will be 4 again because of 132. If we subtract, this will be 18. We add a 0, it will be 5 again because of 165. We just continue like this. This will be 15. If we continue, it will just be 4, 5, 4, 5, 4, 5, continuously like that. So our fraction 15 over 33 into a decimal, it will be 0.45, and the recurring decimals, as you can see, the digits that are repeating themselves are 4 and 5. So we put a dot above 4 and another dot above 5. So that is how we can express fractions into recurring decimals and also recurring decimals into fractions. So our today's topic was decimals. We already know how to change decimals into fractions and fractions into decimals. We have also looked at recurring decimals, whereby we found that recurring decimals are decimal fractions whereby a digit or more repeats itself continuously. So now I want us to look at something else. which is sorry. The next thing that we were supposed to look at was how to round off decimal numbers into required decimal places. So this will be our subtopic, will be rounding off. Rounding off. So I can give examples of how we round off decimal numbers into decimal places. So let us have one example. You can be given any number, for example, a decimal number. You can be given a number like, let's say, 4.5672. Then you are told, round off the following numbers to 1 decimal place, 2 decimal place, and 3 decimal places. So when this number, if we have our number here as 4.5672, we're supposed to round it first to 1 decimal place. So if you look at this number, it has 4 decimal places. But now we are being told to round it to 1 decimal place. So to 1 decimal place, it means that our digit here that we are going to look at is 5. But now we won't look at 5. We are going to look at the digit that is after 5, such that if that digit is above 5, we make all the other digits on the right 0, then we add 1 to the previous digit. So as we can see, our 6 here, it is above 5. So we're going to make this one a 0, then we have a +1 here to the previous digit. So this number to 1 decimal place will be 4.6. And the other digits will all be 0. So this one can also be written as 4.6, just like that. So if we have to 2 decimal places, our digit is 4.5672. To 2 decimal places, 1, 2, we're going to look at 7. 7 is above 5, as you can see, so we're going to add 1 here again. So we have our number as 4.5, then 6 plus 1, this will be 7. Then the other digits will be 0. So this one will be the same as 4.57. Then lastly, to 3 decimal, this was to 2 decimal places. This was to 1 decimal place. And lastly, we are supposed to also convert that into 3 decimal places. So to 3 decimal places, our number being 4.5672, if we convert that to 3 decimal places, we are going to count 3 decimal places. Then we look at the number after that, which is 2. As you can see, it is less than 5. So we just make it a 0. There will be no +1 since it is less than 5. So if that will be 0, we have our number as 4.5670, which is also written as 4.567. This was to 3 decimal places. So that is how we round off numbers to 1, maybe 1 decimal place, 2 decimal place, or 3 decimal places. You just look at the number afterwards and see if that number is above 5. If it is above 5, you add 1 to the previous number. So after that one was a bit simpler. I want us now to look at, maybe let us still look at rounding off, but now you can be given a number like, let's say a number like 97,643. Then you're told, round off this number to the nearest hundreds. If you've been told to round off that number to the nearest hundreds, first of all, you have to identify the place value of each digit in this number. So if we have, this is 97643. This will be ones, tens, hundreds, thousands, then 10,000s. So we've been told to round off that number to the nearest hundred. As you can see, the the digit which is at hundreds is digit 6. But we are going to look at the previous digit, because this one, the 6, it is the one that will be affected. It will either, if the digit afterwards is above 5, we are going to add 1. If it is less than 5, we are going to just make the digits on the right be zeros. So as you can see here, the previous digit here is 4. So if it is 4, 4 is less than 5, whereby we're just going to make this other digits 0. So our number will be 97,600, because our previous digit was less than 5. So this is the number when it is converted to hundreds. I now want us to look at, I had remembered that we were supposed to look at that. I now want us to look at how standard forms, how numbers are written in standard form. So this is our next subtopic, standard form. Standard form. So we say that a number is said to be in standard form if that number is more than 1 and it is less or equals to 10. For example, a number, we are saying a number in standard form, it is, first of all, it is written as a times 10 power n. This is how a number in standard form is written as, whereby our n is an integer, our value n, where our n is an integer. And we know that integers are positive numbers, positive numbers, or 0. Positive whole numbers, negative whole numbers, or 0. Those are what they form integers. And we've said that a number whereby this a should be greater than 1, and a should also be less, or should be greater or equals to 1, and a should be less than 10. So this is how a number in standard form should be expressed. We've seen that it should be expressed in the form of a times 10 power n, whereby our n should be an integer. And an integer, we've said it is either a positive whole number, a negative whole number, or a 0. And we've seen that that a should be greater or equals to 1, and also it should be less than 10. So the numbers that can be in between a should be from 1 maybe to 9.9, because we've seen that it should be greater than 10. So let us look at how we express the following numbers into standard form. I'll just leave it at there. So you are given a number like 324. So express that number into standard form. We've seen that numbers in standard form are written as that a times 10 power n. So whereby our a should be greater or equals to 1. So we are going to look at a place whereby we are going to place the decimal place in between the numbers, whereby those numbers should be greater or equals to 1 and less than 10. So if we place the decimal place at 32 there, in between 2 and 4, it will be 32.4. And 32.4, you can see already 32 is greater than 10. So this is not correct. So we're going to place the decimal place again there in between 3 and 2. So this will be 3.24. This number, 3.24, this number has already been converted into a standard form, but this will be times 10 power. How many decimal places do we have to move so that we come back to the original number, which was 324? It will be 2. So like that. So as you can see here, this number, we've already expressed our number 324 into standard form, which has been 3.24 times 10 power 2. And as you can see, our n, which was our n here, it is replaced by 2, which 2 is a whole positive number, whereby we've said integers should be either a whole positive number, a whole negative number, or 0. So let us look at another example. You can be given an example like 64.8 6.23. Convert that one into write that one as a standard form. So we're going to, if you look at 64, it is greater than 10. So we're going to replace the decimal. You can't place the decimal in front because that one will make the number larger. So we're going to bring the decimal backwards there. So this will be 6.423. Then times 10 times 10. Then we're going to count how many times have we moved. It will be 1, so that we come back to the original number like that. So this 64.23 written in standard form will be the same as 6.423 times 10 power 1. As you can see, 6.4, it is less than 10 and it is more than 1. So that is another example of how also we write a number in standard form. Then another example, maybe we can say you are given a number like 8.539. Convert that number into standard form. If you look at it already, the number is greater than 1 and it is less than 10. So the number itself is already in standard form. But now, remember that numbers written in standard form should be expressed in form of a times 10 power n. So our number will still remain the same. So this will be given by 8.539. But it will be multiplied by 10 power 0. 10 power 0 so if we have our digits there as 8.539 times 10 power 0, we're going to say that 10 power 0 is the same as 1. So there we have written it as 10 power 0 because this number was already in standard form, because as you can see it is greater than 1 and it is less than 10. So times 10 power 0, this is the same as 1. If we take this number multiplied by 1, it will just remain the same number, which is equal like that one. So that is how we write numbers in standard form. I can give a last example, then we call it a day. So we have convert the following number into standard form. We have, maybe we can be given a number like 0.0362. Convert that number into a standard form. If you look at this number, it is less than 1. So we're going to say that this number will be given by, this will be 3.62 times 10, and if you look at the decimal place, we've moved it toward the right, so this will be a negative. How many times? It was 2 times, so this will be 3.62 times 10 power 2. That is how this number can be written in standard form. If you look at this number, we've converted it, we've made it is greater than 1 and less than 10. Then power times 10 power negative 2, whereby our n now here is represented by negative 2, which our n is an integer because that is a negative whole number. So that is how we do, that is how we express also numbers into standard form. And from there, I think you can all do that. So we've already looked at how we convert fractions into decimal places, and a decimal number into fraction. We've converted that. Then we've also seen how we can solve recurring decimals. We can identify recurring decimals, and from fractions we can also get recurring decimals. Then we've also seen how we can round off a number into specific or into the required decimal places. Then lastly, we've seen how to change numbers into standard form. So that is how we've tackled our topic for today, decimals. Thank you so much for watching. And Madam Immaculate, we are done with today's topic, which was decimals. Thank you so much.